Good evening, all. So, am I audible to everyone? Good evening. Welcome to Sankalp learning classes. So, yesterday we were discussing the chapter integrals, right? So, we'll be continuing the rest of the chapter in today's session. Okay, so you have studied about what is integration is, isn't it? What is integration? Integration is nothing but the reverse process of differentiation. It is a reverse process of differentiation, and the function that we get after integrating a function, that is, after integrating, you will get a function that is a family of functions, isn't it? So what is it called? It is called as integral, or it is known as antiderivative, isn't it? It is called as integral or antiderivative. And we are getting not a single function, we are getting a family of function. So it is known as family of antiderivative. And in order to represent that family, we use a notation called C, that is the constant of integration, isn't it? And uh, we studied different methods of integration as well, isn't it? What was our first method? First method was direct integration, isn't it? We have studied some standard formulas. We have studied some standard formulas of integration, and with the help of these standard results, we solved certain integration using direct integration method. So that was our first type. Okay, now what was our second type? Second time we started with integration by substitution, and integration by substitution itself there are different types. Okay, we are grouping into different types for our reasons. Okay, so the first type was the functions of the form f of ax plus b. The functions of the form f of ax plus b, isn't it? Then we studied the functions of the form f dash of x by f of x, f dash of x by f of x. And then we studied about the third type was phi of f of x into f dash of x dx. What is this phi of f of x into f dash of x dx? It is actually like a composite function, and the function inside that function phi, its derivative will be outside. So that becomes the third type. I'll write it once again here. Okay. So the third type was of the form phi of f of x into f dash of x dx. Okay. So yesterday we stopped here with this type, and today we will continue this integration by substitution itself. But I think this is the fifth type. Okay. Four types we have studied. We'll move on to the fifth type today. So that is integrals of function using trigonometric identities. Okay, we use here trigonometric identities as substitution for the given function, and then we solve that integral. All right. Have you got it? So in this session, you will be needed the trigonometric identity that we have studied in 10 as well as in the PU1. Okay. So if you are not familiar with those identities, I have written here the identities that we may need to solve the problems in this session. So this is these four you have to study, and similarly this also. Actually, these four results we obtain it from the identities that we have studied in PU1. It is like a rearrangement of those identities. Okay. So we'll start with the problem, then you will understand what I am saying. Okay, so we'll start with the first problem is integral cot square x dx, integral cot square x dx. Okay, So here, do you know any standard result to solve this one, cot square x dx? Have you studied any formula? No. So we can't use direct integration. Then you think whether we can use a first time. Then if you have to use a first time, then the function should be of the form f of ax plus b. That is, the function should have a linear polynomial in the place of x. Here it is just a trigonometric function. So we can't apply that type. So it is not of the first type. Now you think about the second type. Second type is of the form f dash of x by f of x. Isn't it f dash of x by f of x form? That is, the derivative of the denominator will be on the numerator. So it is not the second type also. Here you can't see any derivative, or it is not of the rational function form. Now you think about the third type. Third type is phi of f of x into f dash of x dx. This is not in that form also. So we need some other method to solve this one. That is integral cot square x dx. For that we use substitution method, but we use trigonometric identity for substitution. All right. So you think whether there is any identity connecting cot square and the standard results. Okay. Is there any identity connecting like that? We know cosec square x minus, we know cosec square x minus cot square x. What is the value of cosec square x minus cot square x? Cosec square x minus cot square x. What is the value of this identity? It is nothing but 1. Cosec square x minus cot square x is equal to 1. So from that, can you write what is cot square x? From that, can you derive what is cot square x? You can place this cosec square x here itself. You take this 1 to this side. So cosec square x minus 1. And you take this minus cot square x to the other side. So this is equal to cot square x. Cosec square x minus 1 is equal to cot square x. So we have an identity connecting cot square x. And this one we know the integral of cosec square x as well as 1. Isn't it? We studied it in the standard result. The cosec square x integral of cosec square x. Okay. So we can substitute cot square x. Instead of cot square x, we can use the identity cosec square x minus 1. So this is equal to, this will become integral cosec square x minus 1 into dx. Cosec square x minus 1 into dx. Alright. Now, we can split the integrals. It is a property of integral that we can split the integrals. Isn't it? Split the integrals into two functions. So this will become integral cosec square x dx. Cosec square x dx minus integral 1 dx minus integral 1 dx. And what is integral cosec square x? So you think about the derivative. Which derivative is cosec square x? Which function's derivative is cosec square x? Cot square x derivative, sorry. Cot x derivative is minus cosec square x. The derivative of cot x is minus cosec square x. So what will be the integral of cosec square x? Integral of cosec square x will be minus cot x. Okay, so this is equal to minus cot x. This is equal to minus cot x minus, what is integral of 1 into dx? Yesterday we studied the result, isn't it? Integral 1 dx is nothing but integral dx itself. So the value is x. Okay, minus x. Then we have to definitely add c, the constant of integration. So what is the integral of cot square x dx? Minus cot x minus x plus c. All right. Now we are moving on to our second question. So the second question is integral 1 minus cos x divided by 1 plus cos x into dx. Okay. Here also we need to apply a trigonometric identity. So which identity should be used here? Which identity should be used here? So 1 minus, we need the value for 1 minus cos x as well, 1 plus cos x. Okay. So here I'm going to use the identity cos 2x is equal to 1 minus 2 sine square x. Cos 2x is equal to 1 minus 2 sine square x. Here we need cos x. Okay, that is half of 2x. Half of 2x is x. So I am making this into half angle formula. So take half angle. Cos of 2x will become cos x is equal to 1 minus 2 sine square x. So sine square x, when you take half of that angle, it will become 2 sine square x by 2. 2 sine square x by 2. So what will happen? we need 1 minus cos x. We need 1 minus cos x. So you take 2 sine square x by 2 to this side. So what will happen? This is equal to 1 minus cos x. 2 sine square x by 2 is equal to 1 minus cos x. So we have got the identity for 1 minus cos x. What is it? What is it? 2 sine square x by 2. 2 sine square x by 2. So this can be replaced. 1 minus cos x can be replaced with 2 sine square x by 2. 2 sine square x by 2 divided by. Now we need to change 1 plus cos x also into some trigonometric identity that will help us to apply the standard result and solve the problem. Okay, that is our intention. So here also I'm going to take the identity cos 2x is equal to 2 cos square x. Cos 2x is equal to 2 cos square x minus 1. This is also an identity for cos 2x. Okay, so here also if you take half angle, it becomes cos x is equal to 2 cos square x by 2 minus 1. 2 cos square x by 2 minus 1. And we need 1 plus cos x. We need 1 plus cos x. So you take this minus 1 to this side. So this becomes cos x plus 1 is equal to 2 cos square x by 2. So what is 1 plus cos x? 1 plus cos x is nothing but 2 cos square x by 2. So in the place of 1 plus cos x, I am going to replace it with 2 cos square x by 2 dx. Alright. If this procedure is finding difficult for you, you do one thing, that you study these formulas. Okay, here I have written here sine square x is equal to 1 minus cos 2x by 2. From this you can directly write 1 minus cos 2x is equal to 2 sine square x. But here we need only 1 minus cos x. So you can write this one as 2 sine square x by 2. Okay, I think this will be a little bit easier for you. So you studied all these four formulas. Cos square x is equal to 1 plus cos 2x by 2. So if you are asked to substitute 1 plus cos x, okay, here it is cos 2x. If you are asked to substitute 1 plus cos x, then what you have to do? You have to take this 2 to this side. So this will become 2 cos square x. But we need only cos x. So you take half of that angle. So this cos square x, 2 cos square x will become 2 cos square x by 2 when you are finding 1 plus cos x. Okay, so you study all these formulas. Now, we are moving on to our third question. Sorry, we can complete this one. Here, 2 and 2 gets cancelled, isn't it? 2 and 2 gets cancelled. What is sine square x by 2 by cos square x by 2? Sine square x by 2. Sine square x by cos square x is sine x by cos x is tan x. So sine square x by 2 by cos square x by 2 will become tan square x by 2 dx. Tan square x by 2 dx. And what is this tan square x by 2? Is there any trigonometric identity? We don't know the standard result for tan square, isn't it? So is there any trigonometric identity? We can replace this one as sec square x by 2, sec square x by 2 minus 1. Sec square x by 2 minus 1. Because we know sec square x minus tan square x is equal to 1. So from that you will get sec square x minus 1. You take this 1 to the other side. So it will become sec square x minus 1 and take minus tan square x to the other side. It is equal to tan square x. Okay, so sec square x by 2 minus 1. Here it is x by 2. So take half of the angle. Okay, tan square x is sec square x minus 1. Okay, so if it is half angle tan square x by 2, then you write sec square x by 2 minus 1. Okay, so we have got the substitution. Now we can split the integrals, isn't it? We can split the integral. That is, we can split this one as sec square x by 2, sec square x by 2 dx minus integral 1 dx, integral 1 dx. So this is equal to, what is the value of integral sec square x? Integral sec square x is nothing but tan x, isn't it? It is tan x. Here sec square x by 2. So it is tan x by 2. Here it is sec square x by 2. So it is tan x by 2 minus integral 1 dx means x, isn't it? Integral 1 dx means it is x. Tan x by 2 minus x, then we have to definitely add a plus c. Okay, so this is our result. And here we need, you should not forget to divide the, I'm sorry, it is not complete here. In the place of x, you can see it is not tan x, it is tan x by 2. In the place of x, it is a linear polynomial x by 2. X by 2 is a linear polynomial. So what we have to do? We have to divide the obtained function. Divide the obtained function with the derivative of the linear polynomial, isn't it? We have studied in the first type, that is f of ax plus b. We have to find the integral as usual, but we have to divide the derivative of this linear polynomial. So in every case, the derivative of a linear polynomial will be the coefficient of x. That is, in this case, the derivative will be a. F of ax plus b, because the coefficient of x is a. So the derivative will be a. So divide it with a. Here you can see that it is x by 2. So what is the coefficient of x? You can write x by 2 as 1 by 2 into x. So what is the coefficient of x? Coefficient of x is 1 by 2. So divide it with 1 by 2. 1 by 2 means reciprocal when you take to the take it above, that is into 2 by 1. It will become into 2 by 1. So this is 2 tan x by 2 minus x plus c. 2 tan x by 2 minus x plus c. All right. I hope this question is clear to you. Now we are moving on to the third question. Integral cos 4x into sin 3x dx. Okay, so think whether there is any identity for cos x and sin x. Cos x into the product of cos x and sin x. Is there any identity? Have you studied this one? 2 sin a cos b equal to sin of a plus b plus sin of a minus b. Okay, 2 cos a sin b is equal to sin of a plus b minus sin of a minus b. And similarly, there are two more identities. Okay, so here I'll tell you a quote. If it is useful to you, you can use it will be good for you to memorize these identities. Okay, actually, this is I'm grouping it into two as same functions. Okay, I'm taking the first letter of the functions, that is cos I'm taking c, and for sine I'm taking s. Okay, so 2cc is equal to c plus c. Okay, that means 2 into cos x cos y equal to cos of x plus y plus cos of x minus y. Okay, here I used x and y. In this one they have given it as a and b. Okay, you can use any variable. So 2 cos x cos y is equal to cos of x plus y plus cos of x minus y. The short form of that is 2cc is equal to c plus c. Okay, similarly, you can group all these four in that way. Okay, 2cc is equal to c plus c. Next one is minus 2ss is equal to c minus c. Okay, now the third one is 2se equal to s plus s, and 2cs is equal to s minus x. Okay, what is the c and s? 2 sin x cos x. 2 sin x cos x is equal to sine of x plus y plus sine of x minus y. 2 cos x sin y is equal to sine of x plus y minus sine of x minus y. Okay, again, here also similarly. Okay, now we are moving on to our question, that is integral cos 4x sin 3x dx. Integral cos 4x sin 3x dx. Okay, so what will be the trigonometric identity that I am going to substitute here? It is of the form CS. CS. So it is S minus S. But it was 2CS, isn't it? It was 2CS S minus S. But here you can see that there is only cos x and cos y. Sorry, sin y. Cos x and sin y is there, 2 is not there. So what you have to do, you have to take this 2 to the other side. So this will become 1 by 2 into s minus s. So what will be the trigonometric identity that I am going to use here? This is equal to 1 by 2 integral 1 by 2 into sine of x plus y. Here what is x? Here in the place of x it is 4x. And what is y? This is x and this is y. Okay, cos x sin y. It is of the form cos x sin y. Okay, so here 1 by 2 into sine of x plus y. X plus y means 4x plus 4x plus 3x. Okay. Then minus sine of x minus y. X minus y means 4x minus 3x. 4x minus 3x into dx. Okay, so this is equal to integral 1 by 2 into sine 4x plus 3x means sine of 7x minus sine of 4x minus 3x means sine x dx. All right, now you separate these integrals. 1 by 2, it is a constant. We can take it outside. And then you find the integral of sine 7x. What is integral of sine 7x? What is integral of sine 7x? We know the integral of sine x is minus cos x. Integral of sine x is minus cos x plus c. Minus cos x plus c. Isn't it? But here in the place of x, it is 7x. 7x is a linear polynomial. 7x is a linear polynomial. So we can assume it as x. Okay, we can assume any linear polynomial as x and find the integral as usual by applying the standard result. But the condition is that you should never forget to divide the derivative of the linear polynomial with the result. Okay, so if it is sine 7x, what happens there? Sine 7x, integral of sine 7x is minus cos 7x minus cos 7x. Okay, sine x is cos minus cos x. So sine 7x is minus cos 7x. But in the place of x, it is 7x. So you have to divide it with the derivative. What is the derivative of 7x? 7x is nothing but 7. Okay, so minus cos 7x by 7 plus what is the here what is, just a minute. So what is the integral of sine x? Next term is integral of sine x. Sine x is cos x plus c, isn't it? So minus cos x plus c. So there is already a minus there. Then minus cos x plus c. So this can be written as 1 by 2 into minus cos 7x by 7 plus cos x plus c. Okay, so this is our integral. Now, I hope this was useful to you all because there are more questions of this type. So you can practice it from your textbook. There are different types of questions that is in the same pattern that we have discussed. Okay, by applying these trigonometric identity, you can solve it. Okay, now we are moving on to the next type. Okay, that is integration of some special functions. Uh, Actually, in this topic, there are only 6 formulas that you have to study. These 6 formulas you have to study. But I have taken 3 other formulas also. It is from the another session. Okay, the proof of that results comes in another section, that is 7.6. But we are clubbing it together in order to study the formulas in an easy way. Okay, to memorize it in an easy way, we'll take that 3 formulas also in this session, these 3. Okay, so you don't have to worry about this. I'll tell you an idea how to study these formulas. That is here. You can see so how to find out the integral. Do you know how to find out integral of 1 by a square plus x square into dx? We don't know, right? So we'll be deriving this result, how to find integral 1 by a square plus x square. The derivation of all these formulas are important. In this class, we'll be discussing the derivation of the first one and some problems that uses all these formulas. All right. So the first one is you can see that it is 1 by a square plus x square, or you think it is 1 by x square plus a square. Both are same, isn't it? 1 by a square plus x square and 1 by x square plus a square, both are same. And the second one, you can see it is 1 by x square minus a square, x square minus a square. And the third one, you can see it is 1 by a square minus x square. Now you see these 3 formulas. Is there any connection? It is the same, but you can see that in the denominator there is a root, isn't it? Here this one is x square plus a square, then this one is root of x square plus a square. This is x square minus a square, this is root of x square minus a square. This is a square minus x square, and this one is root of a square minus x square. Now we'll take the other 3 also. Now see this. Is there any connection here? It is not of the form 1 by a form. Okay, this is just integral root of x square plus a square, integral root of x square minus a square, and integral root of a square minus x square. Okay, So we'll club this 9 formulas together and we'll study it. Okay, so what is 1 by a square plus x square? We know integral of 1 by 1 plus x square is tan inverse x, isn't it? Tan inverse x. This one we have studied. Actually, this one is a special case of this formula. Okay, these formulas are very important because you have to use these formulas in application of integrals as well. So you have to study this properly. Okay, so 1 by a square plus a square is equal to, what is the formula? 1 by a tan inverse of x by a plus c. Okay, so you connect it with this one. You know 1 by 1 plus x square. In the place of 1, here it is a. In the place of 1, here it is a. So there is an extra thing 1 by a and there is x by a also. Okay, 1 by integral of 1 by a square plus x square is 1 by a tan inverse of x by a plus c. Now you take the second one, it is integral 1 by, it is integral 1 by x square minus a square into dx. So this one you can see that it is 1 by 2a log mod x minus a by x plus a plus c. You don't have to worry about thinking all these formulas. You just make some connection to memorize these formulas. Okay, that is x square minus a square. You can factorize this as x minus a into x plus a, isn't it? X square minus a square can be written as x plus a into x minus a. These are the factors of this one. So you connect it in that way. You write log of x minus a divided by x plus a. Okay, now you take the third one. It is 1 by a square minus x square. Again, the factors are a plus x and a minus x. So you write a plus x above and in the denominator a minus x. 1 by 2a log mod a plus x by a minus x plus c. Okay, now you consider the other one. Okay, so this one 1 by root of x square plus a square, that is log mod. First you write log, then modulus of x. Okay, here it is x, so you put here x, then plus you write the question itself. What is the question? Root of x square plus a square, that is root of x square plus a square plus c. Now you consider second one, integral 1 by root of x square minus a square into dx. Okay, here also it is of the form log of modulus of x plus, here in the place of x it is x itself, so x plus, then you write the question, that is root of x square minus a square plus c. Okay, now this one is slightly different from all these, and this is an important one also. What is it? Integral 1 by root of a square minus x square is equal to sine inverse of x by a. It is equal to sine inverse of x by a plus c. Okay, now you go on to the other three formulas. So this is a root of integral root of x square plus a square dx. That is equal to, you write first x by 2. Okay, x by 2, then you write the question itself, root of x square plus a square, plus you take the second one, that is a square by 2 log mod x plus root of x square plus a square plus c. Okay, a square by 2, then the previous formula itself. Okay, what was it? X square plus a square is equal to log mod x plus root of x square plus a square plus c. So here also the second term is same like that. Log of x plus root of x square plus a square plus c. Now you consider integral root of x square minus a square into dx. Again, first you write x by 2, then you write the question root of x square minus a square by 2 log mod x plus root of x square minus a square plus c. Okay, the last one is integral root of a square minus x square into dx. Again, you write x by 2, then you write the question root of a square minus x square plus a square by 2 sine inverse of x by a plus c. Okay, so all these formulas, the derivation is also important. These three, the derivation comes in the integration by parts method. Okay, that we'll discuss there. And in this session, we'll discuss the derivation of the first one. Okay, 1 by integral 1 by a square plus x square dx is equal to 1 by a tan inverse of x by a plus c. Okay, let's start. Consider the integral 1 by a square plus a x square into dx. Okay, so here also I am going to make a substitution. So I am going to put x is equal to a tan theta. put x is equal to a tan theta. Okay, so what will be dx? What will be dx? With respect to x, I am going to derivate this. Okay, d by dx of x is equal to d by dx of a tan theta. A tan theta. So d by dx of x is d by dx of x is 1. 1 is equal to a is a constant, so we can take it outside. Tan theta is a function, but we are differentiating it with respect to x. So differentiate it as usual. Tan theta, we know the derivative is sec square theta, but the function is not in x, but we are differentiating with respect to x. So what you have to do? You have to multiply dx by, sorry, d theta by dx. Isn't it? We are differentiating it with respect to x. So it is into d theta by dx. All right. So this is a sec square theta into d theta by dx. So you take this dx to this side. So dx is equal to a sec square theta d theta. A sec square theta d theta. Alright. Now we can write this 1 into dx means dx itself, isn't it? So this can be written as dx by a square plus x square. Here I have made a substitution. X is a tan theta. And we have got dx is equal to a sec square theta d theta. So this will become integral a sec square theta d theta divided by a square plus what is x? X is a tan theta. A tan theta the whole square. A tan theta the whole square. Alright. So this is equal to integral a sec square theta divided by here a square plus a square tan square theta d theta. Alright. Alright. Now we can take that a square from the denominator outside. Okay, so this will become a sec square theta divided by a square into 1 plus tan square theta. 1 plus tan square theta d theta. So what is 1 plus tan square theta? It is nothing but sec square theta. So this will become integral a sec square theta divided by a square into sec square theta d theta. Alright, a and 1a gets cancelled. So this will be sec square theta and sec square theta gets cancelled. So what is remaining there? Integral 1 by a d theta. 1 by a is a constant, 1 by a can be taken outside. So 1 by a integral d theta. So which means 1 by a integral dx is x plus c. Okay, so here we are integrating it with respect to theta. So integral dx is nothing but theta plus c. Integral d theta is nothing but theta plus c. So this is equal to 1 by a into theta plus c. 1 by a into theta plus c. And what is this theta? We have put x is equal to a tan theta in the beginning, isn't it? X is equal to a tan theta. So you take this a to the side. X by a equal to tan theta. X by a equal to tan theta. So what is theta from this? Theta is equal to, you keep this theta there in the right side. So this will become tan inverse of x by a. Tan inverse of x by a equal to theta. So you can replace this one theta with tan inverse x. So this will become 1 by a tan inverse of x plus c. 1 by a tan inverse of x plus c. Okay. So we have derived the formula for which integral? For the first one. What was it? Integral 1 by a square plus x square is equal to 1 by a tan inverse x by a plus c. Alright, now we'll do some problems from this session. First one is integral 1 by x square plus 25. 1 by x square plus 25 into dx. How will you solve this? Is this of the form 1 by x square plus a square? It is not of the form a square. Can we change this 25 into some a square form, into some numbers power? Yes, definitely. Because 25 is 5 square. So we can rewrite this one as integral 1 by x square plus 5 square. Isn't it? 25 can be written as 5 square. So it can be written as 1 by x square plus 5 square into dx. And now can we apply the result? Integral 1 by x square plus a square into dx is equal to 1 by a tan inverse of x by a plus c. Can we apply this? Yes. Isn't it here in the place of a? It is 2. Here a is equal to 2 and x is x itself. So what will be the value of this integral? It is nothing but 1 by a. 1 by a means 1 by 5. 1 by 5 tan inverse of, in the place of x, it is x itself. So x by, in the place of a, it is 5. So x by 5 plus c. 1 by 5 tan inverse of x by 5 plus c. Okay, now we'll do one more problem. Integral dx by x square plus 3. Integral dx by x square plus 3. It is same as integral 1 by x square plus 3 dx. Okay, I wrote that dx on the numerator side. That's all. So can you compare it with 1 by x square plus a square? Can you compare? Here we don't know the root of 3. What is root of 3? Root 3 itself, isn't it? So we can write 3 as, we know root 3 into root 3 is equal to 3. So we can write this 3 as integral dx by x square plus root 3 the whole square, isn't it? Root 3 the whole square is nothing but 3. So now can you compare it with this one? 1 by x square plus a square. Here in the place of a it is root 3 and in the place of x it is x itself. So what will be the integral value? Integral value will be 1 by a tan inverse of x by a plus c. So here a is root 3. So 1 by root 3. 1 by root 3 tan inverse of x by root 3. X by a means x by root 3 plus c. Alright. Moving on to our next question. Integral 1 by x square minus 16 dx. 1 by x square minus 16 into dx. Okay, so can you convert this into any result that we have studied now? Can we write this one as integral 1 by x square minus a square? We know the result for this one, isn't it? Integral x square minus a square, we have studied it. 1 by 2a log mod x minus a by x plus a plus c. Isn't it? That was our result. So can we change this one into that result? Yes, because the 16 can be written as 4 square. So we can change this into 1 by x square, 1 by x square minus 4 square dx. 1 by x square minus 4 square dx. Now, can you compare it with this one? Here in the place of a, it is 4. A is equal to 4. In the place of x, it is x itself. Now, this is of the form integral 1 by x square minus a square. So, x square minus a square is nothing but 1 by 2a. It is, I'll write here 1 by 2a log mod x minus a by x plus a plus c. Okay, this is our value of this result. Okay, integral 1 by x square minus a square. Here, you have to substitute a as 4, isn't it? So 1 by 2 into 4 log mod x minus 4 divided by x plus 4 plus c. X minus 4 by x plus 4 plus c. So what is 1 by 2 into 4? 1 by 8 log mod x minus 4 by x plus 4 plus c. Okay, so this is our integral value of 1 by x square minus 16 dx. Alright, moving on to our next question. Integral 1 by root of 25 minus x square into dx. Integral 1 by root of 25 minus x square into dx. Okay, so can we write this one as integral? So this is the second set. Okay, this one. This one. Sorry, 25 minus x square. It is a square minus x square. It is of the form a square minus root of a square minus x square form. Okay. Isn't it? 25 can be written as root of 5 square minus x square. Now, this became the form 1 by root of a square minus x square dx. 1 by root of a square minus x square dx. It is nothing but sine inverse of x by a plus c. Sine inverse of x by a plus c. So here what you have to do, you have to identify which is in place of a. Here a is equal to 5. Okay, so what will be the integral value? Sine inverse of x by 5 plus c. Sine inverse of x by 5 plus c. Alright, moving on to our next question. Integral 1 by root of 2 minus x the whole square, root of 2 minus x the whole square plus 1 square into dx. Okay, here can you compare it with the any formulas that we studied now? It is like integral 1 by root of x square plus a square, root of x square plus a square. But in the place of x, you can see that it is 2 minus x. In the place of x, it is another function. It is a linear polynomial 2 minus x. And in the place of a, it is 1. Okay, so we have already studied that we can assume a linear polynomial as x and apply the standard. All the standard results we can apply, but the condition is that you have to divide the derivative of that linear polynomial. Okay, so and the derivative of a linear polynomial is always the coefficient of x. Coefficient of x, here the coefficient of x is -1, isn't it? 2 minus x means coefficient of x is -1. So we have to divide it with -1. You integrate it as usual, and what you have to do, you have to divide it with -1. So what is 1 by root of x square plus a square dx? What is integral 1 by root of x square plus a square? Here you have studied the formula. Root of x square plus a square is log mode. First you write x itself, then you write the question x plus root of x square plus a square plus c. Okay, so applying that result, you will get log mode x. But in the place of x, it is 2 minus x. So you write 2 minus x here. X is equal to 2 minus x. Okay, and what is a? A is equal to 1. Okay, so change it accordingly. So this will become log of 2 minus x. X in the place of x, it is 2 minus x. Plus, you write the question itself. That is root of 2 minus x the whole square plus 1 square plus c. Now you can't stop here because we have assumed x as 2 minus x. So we have to divide it with the derivative of 2 minus x. 2 minus x derivative is -1. So this will become minus log modulus of 2 minus x plus root of 2 minus x the whole square plus 1 square plus c. Alright, now moving on to our next question, that is integral root of 4 minus x square dx. Okay, this is the third set. Okay, root of 4 minus, it is not of the form 1 by form. Root of 4 minus x square dx. So you change this into that form, that is integral root of 4 can be written as 2 square. 2 square minus x square into dx. Integral root of 2 square minus x square into dx. So what is the result? Integral a square minus, sorry, root of a square minus x square into dx is equal to, you write x by 2 first, then you write the question, that is x by 2 root of a square minus x square, then plus a square by 2 sine inverse of x by a plus c, sine inverse of x by a plus c. So this is the standard result. Now you compare these two. Here in the place of a it is 2 and in the place of x it is x itself. Okay, so this result will be integral root of 2 square minus x square dx is equal to x by 2 root of 2 square minus x square plus a square by 2. What is a square? A square is 4 by 2. 4 by 2 sine inverse of x by, what is a here? A is 2. X by 2 plus c. Okay, so this is equal to x by 2 root of 2 square minus x square. We can cancel this, isn't it? So plus 2 sine inverse of x by 2 plus c. Sine inverse of x by 2 plus c. Alright. So we'll end this type here and we'll move on to the next type. So this was our type 6, isn't it? Now we are moving on to the type 7. Okay, so if you know the type 6, then it will be easy to solve the problems in type 7. Actually, it is like an extended version, type 7. That is, it will be of the form, the polynomials which are of the form dx by ax square plus bx plus c. Then the functions which are of the form dx by root of ax square plus bx plus c. And third one is integral root of ax square plus bx plus c into dx. Okay, so we'll see how these type of functions are solved with the help of type 6. Okay, actually here you can see that in the denominator and all, it is a standard quadratic polynomial. So what we are going to do is that we are going to change this into type 6. So to apply type 6, it should be like a perfect square, isn't it? This one is not a perfect square, it's a standard quadratic polynomial. So what you have to do is that you have to first change this into a perfect square by applying the completing square method. Okay, completing square method is applied to make it a perfect square. So how will you use that? I'll explain it with the help of an example. All right, so the first question is integral dx by x square minus 6x plus x square minus 6x plus 30. X square minus 6x plus 30. This is of the form type 7, isn't it? Here you can see a quadratic polynomial, second degree polynomial, x square minus 6x plus 13. Now, what you have to do, you have to make it a perfect square. For that, you have to apply the completing square method. That is, you consider the coefficient of x. Okay. First, consider the coefficient of x. Coefficient of x is here. Coefficient of x is 6. You don't need to bother about the sign here. Okay. You just take the coefficient of x. Coefficient of x is 6. And now you take half of it. Half of 6 is 3, isn't it? 6 by 2 is 3. And now you square that number. 3 square is equal to 9. So what I have done here? Take the coefficient of x. Take half of it. Okay, here coefficient of x is 6. Take half of it means it becomes 3. And then square it. 3 square is 9. Okay, now what I'm going to do is that I'm going to add and subtract this 9. Okay, that is integral dx by x square minus 6x, then you add a 9, then you subtract 9 also. Plus 9 minus 9 plus 13. Plus 13. Alright, now you can see that these three terms will form a perfect square. These three terms will form a, first you have to add, then only you need to subtract. Okay, in every case, first you add that number that you are getting here, then you subtract it, and then you should not forget this 13 also. Last number, that is plus 30. Alright, now this is of the form perfect square. You can see it, isn't it? It is 3 into 3. 3 into 3 is 9. 3 plus 3 is 6. Minus 3. Minus 3 plus minus 3 is minus 6. Minus 3 into 3 is 9. So how can you write this in a factorized form? So this will become integral 1 by, dx by x minus 3. I'll write the previous step here. Okay, that will be easy. So this one, it was x square minus 6x plus 9 minus 9 plus 30. Okay, this was our previous step. Now we are going to make this as a perfect square. So this is integral dx by, this one can be written as x square minus, x minus 3 the whole square. Then minus 9 plus 13. What is the value of minus 9 plus 13? 13 minus 9 is 4 and it is plus 4. All right. So if you find it difficult, here you can see that you take the root of x square. Root of x square is x and you put the sign. Second sign is minus, then you put minus here. Then you take the root of the third term. Root of third term is root of 9. Root of 9 is 3. So this is x minus 3 the whole square plus 4. Okay, now can you compare it with the type 6? Is this of the form type 6? Type 6 is integral 1 by x square plus a square. One of the result was 1 by x square plus a square. But in the place of x, you can see it is a linear polynomial x minus 3. So we can assume it as x and we can apply the standard result. Okay, so integral dx by x minus 3 the whole square plus 4, we can apply the result of x square plus a square dx. What is it? 1 by a tan inverse of x by a plus c. 1 by a tan inverse of x by a plus c. Here in the place of a, it is 2 because you can write this 4 as 2 square, isn't it? Integral dx by x minus 3 the whole square plus 2 square. So this is equal to, this will be a is equal to 2 and here x is x minus 3. X is x minus 3. Okay, so what you have to do, you have to divide the derivative of the linear polynomial. Here the derivative of this linear polynomial means coefficient of x. Coefficient of x is 1. Coefficient of x is 1, isn't it? So if you divide a function with 1, that is that function itself. Okay, so here if you apply the result, it will become 1 by 2. In the place of a, it is 2. 1 by 2 tan inverse of, in the place of x, it is x minus 3 divided by 2, x by a, x by 2 plus c. Okay, 1 by 2. So divide, whole divided by 1. This is same as 1 by 2 tan inverse of x minus 3 divided by 2 plus c. Okay, so this is our value of that integral. Now we are moving on to the next type. Not next type, next question of this type. All right. So it is integral dx by, and if you get a question like this, integral dx by root of x square plus 2x plus 2. Here, how will you solve this one? How will you solve this one? It is same as the same procedure that we done in the first question itself. The only thing is that here it is root of. So you take the second set of results that we studied in type 6. That is along with root 1 by root of x square plus a square. You change this one into that form and then apply the result. How will you do it? I'll give you a hint. Okay, how can you do it? First, you have to change this into perfect square. Change this into perfect square means first you take the coefficient of x. Take the coefficient of x means here coefficient of x is 2. Now you take half of it. That means 2 by 2. Half of 2 is 1. Half of 2 is 1. Then you take the square of it. 1 square is again 1. So which is the number that you have to add and subtract? It is nothing but 1. So you can change this one into integral dx by root of x square plus 2x. You add a 1. First you add 1. Then you subtract 1. Then you should not forget this 2 also. Then plus 2. Okay, so this will become integral dx by root of, this is like a perfect square, right? So take the root of this x, then put the sign, second sign here, then take the root of 1. So it is x plus 1 the whole square. Then minus 1 plus 2. Minus 1 plus 2 is plus 1. Now this became of the form integral 1 by root of 1 can be written as 1 square, isn't it? Root of x square plus a square. Root of x square plus a square is log mod x plus root of x square plus a square plus c. Now what you have to do is that you have to put the value of a as 2 and then you will get the answer for that question. Okay, that I'm not doing completely. So we are moving on to the third question. Okay, you do it as a homework. Now we are moving on to the third question. This is integral dx by 9x square plus 6x plus 5. Okay. Here you can say that it is a quadratic polynomial, but to make a to use that perfect square method, the condition is that the coefficient of x square should be 1. Coefficient of x square should be 1. Then only we can apply it directly. So here you can see that the coefficient of x square is 9. So what you have to do, you have to make the coefficient 1. For that, I'm going to take 9 from each of these terms. Okay, I'm going to take 9 from each of these terms. So you have to, in these, you know, there is no 9. So you have to divide a 9 to make it equal. Okay, that is, I'll write it here. It is integral dx by, I'm going to take 9 from x square. So this will become x square itself. But in 6x, there is no 9. So it will become 6 by 9. 6 by 9x plus 5 by 9. Okay. So this is equal to integral dx by 9 into x square plus this we can cancel it with 3, isn't it? So 2 by 3x plus 5 by 9. 2 by 3x plus 5 by 9. Okay, 1 by 9 we can take it outside. Now this is of the form dx by x square plus 2 by 3 into x plus 5 by 9. 2 by 3 into x plus 5 by 9. Here you can apply here the coefficient is 1. Coefficient of x square is 1. So we can apply the completing square method and make it a perfect square. How will you do it? Take the coefficient of x. Take the coefficient of x. Here the coefficient of x is 2 by 3. Coefficient of x is 2 by 3. So 2 by 3. Half of 2 by 3 means 2 by 3 divided by 1 by 2. 2 by 3 divided by 1 by 2 means 2 by 3 into 2. I'm sorry. I'm really sorry. 2 by 3 divided by 2. Isn't it half of 2 by 3? Half of 2 by 3 means 2 by 3 divided by 2. So this will become into 1 by 2. Okay, so this will get cancelled. So the value is 1 by 3. Okay, half is 1 by 3. We need to take the square of half. 1 by 3 square is equal to 1 by 9. Okay, take the coefficient of x, take half of it, then square it. Okay, 1 by 3 square is 1 by 9. So which is the number that we have to add and subtract? It is 1 by 9. So this will become integral, 1 by 9 is outside, integral dx by x square plus 2 by 3x. Then you add 1 by 9, then you subtract 1 by 9, then you this add by 5 by 9 also. So why we are adding this, adding and subtracting to make it equal? Plus 1 by 9 and minus 1 by 9 is actually the value is 0. But here we have to make it a perfect square. That's why we are adding and subtracting 1 by 9. Okay, now this is of the form perfect square. Now we can change this one as integral 1 by 9 was there, right? 1 by 9 dx by 9 into x square plus 2 by 3 into x plus 1 by 9 minus 1 by 9 plus 5 by 9. Alright, so this is equal to 1 by 9 integral of dx by dx by this one. You make it a perfect square. You take the root of this one, that is x. X square, root of x square is x. Then you put the second sign, that is x plus. Then you take the root of 1 by 9. Root of 1 by 9 is 1 by 3. 1 by 3 the whole square. Then you add this one, minus 1 by 9 plus 5 by 9. The denominators are same. So you just subtract the numerator. 5 minus 1 is 4. So 4 by 9. So this is 4 by 9. Now can you write this 4 by 9 as 2 by 3 the whole square? 2 square is 4 and 3 square is 9. So we can write 2 by 3 the whole square. So this is equal to 1 by 9 integral dx by x plus 1 by 3 the whole square plus 2 by 3 the whole square. 2 by 3 the whole square. Okay. So this is equal to, this is of the form 1 by x square plus a square. 1 by x square plus a square. But in the place of x, it is x plus 1 by 3. In the place of x, it is x plus 1 by 3. And in the place of a, it is 2 by 3. In the place of a, it is 2 by 3. Okay. The formula is 1 by a. The formula is 1 by a tan inverse of x by a plus c. So here in the place of x, it is x plus 1 by 3 and a is 2 by 3. So what will be the integral? 1 by 9 is outside, okay? 1 by 9 into 1 by a. A is 2 by 3. 1 by 2 by 3. Tan inverse of x is x plus 1 by 3. X plus 1 by 3 divided by 2 by 3 divided by 2 by 3 plus c. Here you can see that x plus 1 by 3 is a linear polynomial. So we can assume it as x. One thing is that you have to divide the derivative of that linear polynomial. Here the derivative of this linear polynomial is 1 itself. So on dividing it with 1, we get the same function, isn't it? So there is no change happening there. That's why I didn't wrote in the beginning. So what is 1 by 2 by 3? Take the reciprocal. It will become 3 by 2. Tan inverse of this x plus 1 by 3 you can cross multiply and write it as 3x. 3x plus 1 by 3. Okay, I hope you know the basic results. Okay, so 3x plus 1 by 3 divided by 2 by 3 divided by 2 by 3 plus c. Okay, so this is equal to, you can cancel this 3. This will become 3. So 3 into 2 is 6. 1 by 6 tan inverse of this 3 and this 3 gets cancelled, isn't it? So this is tan inverse of 3x plus 1 divided by 2 plus c. Divided by 2 plus c. Okay, so this is our value of the integral. Okay. Now, moving on to type 7. Okay, type 7 is actually an extended version of the same. type 6, but this is a little bit more lengthy. Okay, so this is of the form, the integrals which are of the form. So integrals which are of the form px plus q by ax square plus bx plus c, and px plus q by root of ax square plus bx plus c. Okay, so we'll discuss some questions from that. Type 7, it is integral. First one is integral px plus q by ax square plus bx plus c dx, and second one is integral px plus q divided by root of ax square plus bx plus c into dx. All right, so here also there is a procedure, that is we are making a substitution for the numerator part. Here you can see that this is a first degree polynomial, this is a numerator is a second degree polynomial. So in order to solve this one, we make a substitution for the linear polynomial, that is for the numerator we will make a substitution, and the substitution is px plus q, we will write it as some constant a into d by dx of this denominator, that is the polynomial ax square plus bx plus c plus b. Okay, a into d by dx of ax square plus bx plus c plus b. All right, so we'll do a problem, then you will understand properly. All right, so the first one is integral 5x plus 3 divided by x square plus 4x plus 10 into dx. Okay, how will you do this? Integral 5x plus 3 divided by x square plus 4x plus 10 into dx. So actually, if you make a substitution, then we are going to simplify it, and then we can apply the type 6 or the previous any standard results, and then we'll get the integral of the function. So that is the procedure that we are going to do. So first we have to make the substitution, and what is the substitution? We have to make substitution for the numerator 5x plus 3. 5x plus 3 is equal to some constant into d by dx of denominator. What is denominator here? X square plus 4x plus 10. That is the denominator, plus a constant b. Okay. Now, what is the derivative of this function? X square, we know the derivative is 2x. X square is 2x plus, what is the derivative of 4x? 4x is 4. What is the derivative of 10? It is 0. So, a into 2x plus 4 plus b. A into 2x plus 4 plus b. So, we have converted 5x plus 3 as a into 2x plus 4 plus b. Now, our next task is that to find the values of the constants a and b. To find the values of the constants a and b. For that, we are going to equate the coefficients of x. Okay, equate coefficients of x. In both sides, you check which are the terms that containing x. Equating coefficients of x means you check which are the terms that contain x. Here in the left side, you can see that there is only one term, that is 5x. Okay, 5x. So the coefficient of x is 5. So you take that 5. Okay, 5 equal to. Now you come to the right hand side. Right hand side, which are the terms that contain x? If you take this a to inside, a into 2x. A into 2x. So this one we can write it as a into 2x plus a into 4 plus b. A into 4 plus b. So these are all constant terms, isn't it? A into 2x means the coefficient of x is 2a. The coefficient of x is 2a. So 2a, 5 is equal to 2a. So from that you get a is equal to 5 by 2. You take that 2 to the other side. So a is equal to 5 by 2. Now the next one is equate the constant terms. Equate constant terms. Equating constant terms. Which are the constant terms in left side? Left side the constant term. Only constant term is 3. So 3 is equal to. Here which are the constant term? 4 into a. That is a constant. 4a is a constant plus b is a constant. And we know the value of a is 5 by 2. 4 into 5 by 2 plus b. So this 2 and 4 gets cancelled 2, which means it is 10, isn't it? So I'm writing it here. So this is 3 is equal to 10 plus b. 3 is equal to 10 plus b. So what is the value of b from this? What is the value of b from this? 3 minus 10, that is equal to minus 7. 3 minus 10 is equal to minus 7. Okay, so we have got the values for a and b. A is equal to 5 by 2. A is equal to 5 by 2 and B is equal to minus 7. Okay. Now what I am going to do is that I am going to write this 5x plus 3 as A into 2x plus 4. So it is 5 by 2 into 5 by 2 into 2x plus 4 minus 7. Okay, minus 7. So integral 5x plus 3 by x square plus 4x plus 10 into dx. This can be written as, we have made a substitution for 5x plus 3. So we can change the numerator as 5 by 2 into 2x plus 4 minus 7 divided by x square plus 4x plus 10 into dx. Okay, we have changed the numerator. Now we can split this as two separate integrals. That is, you give this x square minus plus 4x plus 10 to both the terms in the numerator. Which are the terms in the numerator? First term is 5 by 2 into 2x plus 4 and 7. So give that denominator to each of them. Split it equally. Okay, so which means the next step will be integral 5 by 2 into 2x plus 4 divided by x square plus 4x plus 10. Okay, dx minus integral 7 by x square plus 4x plus 10 dx. Okay, now you take 5 by 2 constant outside. This becomes integral 2x plus 4 divided by x square plus 4x plus 10 into dx minus 7 into integral 1 by x square plus 4x plus 10 into dx. Now, is this familiar to you? Which type is this? It is of the form f dash of x by f of x, isn't it? Type 3. F dash of x by f of x, because the derivative of x square plus 4x plus 10. What is the derivative of x square? 2x. What is the derivative of 4x? It is 4. So here it is of the form f dash of x by f of x. And what is the result? Log mod f of x. Log mod f of x plus c. Okay, so the first one we can write it as 5 by 2 log mod. What is f of x here? The denominator. It is x square plus 4x plus 10. The second one we have to apply. We have to change this into, first we have to change it to type 7. Then type 6. Isn't it? It is of the form type 7. So I'm taking the second part only, okay? That is integral 1 by x square plus 4x plus 10. I'm just solving this part only. So this is of the form type 7. We have to complete this, use the method completing the square. That is, first you have to take the coefficient of x, that is 4. Then you take half of it, it is 2. Then you take square, that is 2 square is equal to 4. Then you add 4, then subtract 4. So this is integral 1 by x square plus 4x plus 4 minus 4 plus 10 dx. Okay, so this will become integral 1 by, this is x, take the root of this x, then you put plus, then take the root of 4, it is 2, x plus 2 the whole square plus 6 dx. Okay, so this can be written as integral 1 by x plus 2 the whole square plus 6 can be written as root 6 the whole square dx. Root 6 the whole square dx. And what is integral 1 by x square plus a square dx? It is nothing but 1 by a tan inverse of x by a plus c. X by a plus c. Here in the place of x it is x plus 2 and in the place of a it is root 6. So what will be the integral of that function? What will be the integral? Integral is equal to 1 by root 6, 1 by a, tan inverse of 1 by 7 was, sorry, 7 was outside, right? It's not 1 by 7, 7 was outside. 1 by root 6 tan inverse of, here in the place of x, it is x plus 2 divided by root 6 plus c. You have to divide it with the derivative of x plus 2, it is 1. So this will become 7 into 1 by root 6 tan inverse of x plus 2 by root 6. Okay, this is the second part. What was our first part? We have got it as 5 by 2 log mod x square plus 4x plus 10. Now the second is minus 7 into 1 by root 6 tan inverse of x plus 2 by root 6 plus c. Okay, so this is the integral of that particular function. Now we have a few more types. That is, we have integration by partial fractions and integration by parts method, and some more questions were there in the session. So we'll be continuing the remaining of the chapter in the next session. Okay, so I hope this much was clear to you all. So we have studied integration by substitution using trigonometric identity, isn't it? Using trigonometric identity, then we studied integration of some special functions. You have to study all these formulas. Okay, then we studied the extended version of these type 6 itself, isn't it? Type 7 and type 8. Type 7 and type 8, that is integrals of the form ax square plus bx plus c and root of ax square plus bx plus c. Similarly, px plus q by ax square plus bx plus c also. All right, now we'll discuss the rest of the chapter in tomorrow's class. I hope the session was useful to you all. You should study all the formulas that we have discussed in today's class as well as in yesterday's class. All right, thank you.